All right, hi everybody. This is our Kubernetes workgroup device management meeting. This is an ad hoc meeting to discuss. Well, we're gonna, for the first 30 minutes, we'll talk about networking use cases, and then the second 30 minutes we'll talk about uh, device vendors, particularly the AWS chips in particular, but just the device model in general. Um, Mike, do you want to jump in, or do you want me to frame the conversation? How do you want to do this on the multi-net side? I have examples of what the model so far supports around multi-net, the proposed model, not the existing DRA model. We could start there, or we could start at the requirements document. Do you have a thought on that? Or Neha, Mike, someone?
It maybe it's good to set the stage, and then yeah, Mache and Neha have the specific use cases for multi-network. Does that
Okay.
sound good?
So yeah, so by set the stage. Okay, so the context here is, right, you know, we're working on how pods can ask for specialized devices from the platform to be assigned to their pod. And in the case of networking, it's just to the pod, but for other things, it's assigned to individual containers. We've, uh, we have existing DRA. We're trying to look at we shifted it in 130 to a slightly different model where there's more built in to the platform, and the platform has a deeper understanding of what's going on, and we're trying to extend that further in 131. So we have a prototype repository where we're looking at kind of in order to iterate rapidly on different ideas for modeling rather than building it into the Kubernetes code base, which is a lot of things that go along with it. We just have a separate repository where we're sort of iterating quite quickly. And so we put together, well, it's been through many iterations already, but where it's standing right now, we have a bunch of examples of how a user would ask for uh, additional interfaces in their pod. And I know that's not all of the requirements that the networking team has, because there's other things in the document already that really aren't met at this point. But that's the context, from my point of view, of this is about how we can decompose that piece of adding additional interfaces and configuring those interfaces from any other understanding of networking. Just it's really at the device level. So I don't know if Macha or Neha want to discuss from there, or you want me to jump into the examples.
We can jump into the examples. I think that's uh, a good idea. And then as we jump into the examples, I can talk about some of the scenarios, if you're covering the scenarios or not.
Sure. Okay. So let me share.
I don't know if I don't see Mache in the call.
Yeah, I'm here.
Oh,
He
okay.
joins.
Okay. Awesome. Thanks, Mache.
And John, I think we owe you some like explicit examples of what we would envision this
Yeah.
could be used, right? With what you're proposing, I think that's something that we definitely can do. We will try to use. That's something that I want to do at least. Try to use what this repository already has, plus something that where the kind of touch points for what we think doesn't work for us are, right? So
Yeah, the ones I'm aware of right now, there's two areas of particular interest to me. One is there's nothing here touching the default network, right? That's like we're talking about attaching devices to the pod or a container, and we're not getting into, even with the core node stuff. Theoretically, we could take the core node compute resources and make them a device, but we're not doing that anytime soon, if ever. The other big area is that the current capacity model, the way it's designed, has we already know there's some shortcomings even in the use cases we're already covering, but in the multi-network case in particular, this capacity model is really designed about, hey, some driver on the node presents a list of devices that are present, and then we can select one of them and we can configure it and we can attach it to the pod. The problem is, for networking use cases, I suspect there are a lot of cases where the interface doesn't yet exist. So how do we, it's like, I want to create a VLAN interface. It's not that I want to take a VF from an SRIO VNIC and I want to add a VLAN tag on it. That's covered in the model.
Right.
What's not in the model is I want to synthesize out of whole cloth a VLAN interface.
Yeah.
And so those are the kind of use cases, like really concrete, like use cases that I want to see, because that's going to be that level of concreteness is what's going to hit the model.
Mhm.
So let me show you what I have as examples right now in this. So you see there's 8 or 9 multi-net examples. So the context here is this is a pod spec. And again, we're only looking at one pod at a time. In the AI use cases that people keep pushing towards, like multi-pod things, unfortunately, I'd love to do that, but we have to actually deliver something in some near term, so I'm not going there. So the context is, this is what a pod spec looks like, and as a user, I'm writing this pod spec, and I'm saying I need to add like an interface to my
Mhm.
to my pod. So very simplest use case, and this is the claim side. So there's 2 sides to this model. There's the claim side, that's the user asking for the resources, and then there's the capacity side, that's the driver publishing the available resources, and the scheduler does the matchup between them. So that's what I mean by it. It's sort of like things that already exist. On the claim side, there's classes and claims. So classes define some general constraints about the type of device. So maybe we should start there, actually. So from a class perspective, we can define some things like, hey, this is a GPU one, but we'll see some networking ones in a second. But like, this is a device class that uses this driver. That's the only thing I need to specify that's required in what I call a leaf class. There's more description in the README. But basically, the idea here is that, driver owns a set of devices. And so basically we're saying, give me any device owned by this driver. You'd have to, that's not necessarily a logical division, but you can add constraints. So this says, give me any device managed by this driver that is of this model, for example. Let's go look at the networking ones, because there are some interesting networking things we try to cover here. So in particular, okay, so here's an example. Example.com makes a NIC that's an SRIOV NIC. And so this is saying, give me one device from that SRIOV NIC. What a device is defined kind of by the vendor and the driver. And I'll show you an example of what the devices look like in a second. This says, give me one by a different vendor. So in particular for the networking case, so GPUs, they tend to be like, well, I built this workload, I compiled it, I built it with CUDA. Oh, I see there's a hand. So it's going to run on NVIDIA. But with NICs, an SRIOV NIC from Intel or Mellanox, like, I don't care. It gives me the same presentation from a kernel perspective or from a pod's perspective. And so as a user, I don't necessarily want to say I need an Intel NIC. I want to say I just need an SRIOV NIC. And so we added this concept of classes that define a set of classes, and that's what the label selector here is. So what we have here are 2 different classes, one for example.com NICs, one for example.org NICs, but they both have a device type SRIOV NIC in their labels, and then we can create a class that just matches to that. So then the user can ask for this class. They're not going to be restricted to nodes that have example.com NICs or example.org NICs. They can get either node. The hands, let's address the hands before I continue.
So yeah, that's new. So the labels have a meaning.
They have to be decided upon as a community.
What is the previous? Is that class? Basically, you can select classes from classes. Is that what it is? The labels, the selectors? Yeah. Oh, okay.
This is
how does work if I select multiple?
So this is specifically to solve this problem of I want a NIC, but I don't care what vendor it comes from because drivers are tied to vendors, and so classes are tied to drivers.
So John, this is only, I mean, this device type SRIO VNIC, is this a primitive type? Like, I mean, I may not need an SRIO VNIC. I may need a regular VPC NIC or a VNet NIC. This type is you can define what type you want, right?
Yeah, so there's two aspects to that. The vendor, this type is literally just a label. This is
Yeah,
just
exactly. Keep in mind this is just a label. So this is some
a label. I can any damn value can come here.
Yeah, exactly. And basically the keys or that, I think this is where that was my kind of next question, John, to this. Would I use device class to represent not because this is explicit device class, and yeah, I agree with you. This is perfectly fitting like I have Intel Mellanox or GPU. What's that? Representing some specific, and this is appropriate because I'm representing a GPU. I'm representing a network, a SROV or other device, right? Would this be the object that I would want to represent something like I want to connect to VLAN X object?
Okay, great question. So let's go to my yes.
So it's not a class. So because keep in mind, I would imagine all the objects that would state because now I need an object per VLAN. Let's say I have that case, right? So I will have object A connecting to VLAN X, object B connecting to VLAN Y, right? And I would consider those as a kind of class, right? Because that's a class of virtual, just software-based networks. Should I look at that, be so strict, or basically be loose and then use the device class? You have an okay, sorry.
So
what is object A, object B in your example? Sorry.
Yeah, I don't know. That's my question to John, right? What would I use as object? And I think the device class is the answer, but yeah, John, carry on.
Well, so I want to differentiate between selection of the device and configuration of the device. And so you can kind of the class is a composition of those two things, really. It gives you some selection criteria. The class is owned by the administrator, first of all. It's not by the end user. And so the administrator defines a class, and that can be, that provides a set of selection constraints for what devices might satisfy a claim that uses that class. Additionally, the administrator can attach arbitrary configuration objects to that class. Those don't mean anything to they mean something to the driver that's gonna resolve that class. They don't mean anything to anybody else. Yeah. Did you have a question?
Yeah, let me just quickly, when you say administrator, that's the cluster operator or the platform owner?
It could be either. I mean, this will be a cluster admin level privilege, so I tend to
cluster operator then.
Yeah, cluster operator. But the vendors, our expectation is that the vendors, either device vendors or Kubernetes vendors, will pre-provision a bunch of classes, and then the cluster administrator might decide to create their own classes or might not, and claims basically can, at this point, although I have requirements that nudge me in a different direction, at this point, claims can further refine or add on top of the constraints of a class, and they can add additional configuration. So in the case that's showing on the screen right now, we've used a class to define, and the assumption here is there's some driver that will provision a VLAN, and that it uses this config map to decide what VLAN, and we've created a class to do that. The reality is that could be a CRD that's a very sophisticated set of operations that could be done to do all kinds of stuff, and we'll see some more examples where I try to sort of hint at that later. But this example is a class that attaches configuration information. Later, we'll see claims that attach configuration information. We have two hands. I don't know what order they're in.
Yeah, I just have a clarifying question. So yeah, the selection versus configuration is very helpful. In this case, I'm going to target more the configuration aspect, not so much around selection. So just from my understanding, that the pod would be referencing, say, the device claim, and in this case, like the config map or the CR, the custom resource, in this case, will be specifying the VLAN ID and then additional information such as the mastering device, say, in the root network namespace. So if we have, when we do IP link add, blah, 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 the VLAN, we'll be also specifying said like ETH0 is the master for this end. And then we'll have like net1 inside the pod network namespace, correct?
Yeah,
I
so
think so. I see now. I haven't thought that config map example, but that I think we are missing, John. The one example that you just showed before that kind of showed that, and with the config for VLAN. Do you have a full path for this example with the pods definition? Because this is the example that this is the kind of bread and butter for most of our use cases.
right. So let me show you. Somebody's asking where this is. This is in this kubesigs workgroup device management KRM resource model prototype test data. You'll see classes. These are the classes. This is the last one in the classes.yaml.
Right.
Let me show you another example. I was just trying to find it.
Maybe Doug has a hand. Go ahead, Doug.
Actually, I think that I had the same exact question as Zappa did. I was just asking, like, in that arbitrary config, what does that look like, and how am I going to be able to put specific things I need about a network? Say I need IPs from a specific range or something like that.
Maybe other question. Config map, sky's the limit, right? John, can I configure anything beside config map?
Let me show you here.
I had the same
Yeah,
question.
you could
I
use
think you mentioned
CR.
CR can be done, right?
Yeah, so let me show you. Here's a class definition. And it's a selector or a class. That's the two different forms we saw. The definition, it's this. All this is literally I can show you down here. It's an arbitrary list of where is it? Come on. I didn't search for it. Here we go. API namespace name. It's an arbitrary object reference. Since this is at the class
Sky's
level.
the limit. Sky's the limit.
Yeah.
No.
Since it's at the class level, it doesn't even have to be in any namespace because these are cluster scoped. Now there is a claim. The individual claim can also add a config reference. And in order to do that, of course, it's not namespaced because it has to be in the same namespace as the claim. So again, the driver can choose to ignore it, right? Like there's permissions issues with what those. We don't have any visibility into what those configurations are. We're going to pass them on to the driver, and the driver is going to decide whether that user has legitimate authority to do that based on like it's a
So I think my next question. So can you go through the example going from pod? So pod, because you saw that. So pod references a class or a claim, because or there are multiple options. This is where I'm a bit confused.
Okay, great question. Okay, so and
there are templates, and what are those?
Yeah. Okay. So this is why we really need. We need more time. So in this particular case, okay, the pod spec. Let's just look at that real quick. So the pod spec right now looks like this. It's probably going to change because of discussions we've been having. Several of us have been having, but and it'll look a little bit more like the current 131 probably after we're done, but not exactly the same. But this pod spec basically consists of you can point the pod at an existing claim. That allows multiple pods to share the same claim. There's specific use cases around that. I don't think you necessarily have that use case for networking. Then the other one is you can just create a list of class name pairs. That's this. So again, the reason there's a name, it's like volumes, right? They have to be mounted into particular containers. For you in networking, the pod sandbox, you don't need to mount in particular containers, so the name basically is meaningless. So what this form would allow you to do is just basically list a bunch of classes, and then you get one device from each of those classes. So this is what my sort of different examples in here
So
step
is device claim can you show me an example of a device claim in your classes, how that looks and
Yeah,
how
let's step through what I'm going to do, because
Okay.
I'm jumping around. Like, let me
Yeah.
step through these examples, build in complexity. So let's start with a really simple one. All this does is say, add one device from this class. So give me an example.com, that's the vendor, SRIOV VF. Give me one. That's it. So that's all you have to
John,
do.
to give some context here, this is what we talked about pod network, right? Let's assume the example.com, the class, is our pod network, what we just discussed for the last year.
Mhm.
And basically here, I just arbitrarily connect without any extra configuration. Whatever is in the class, I connect to this pod network.
Yeah.
It has its configuration because it's already hard-coded there. And then I can multiply this across multiple pods, right? I can pass this, I assume, to a deployment, right, John? Because
Correct.
it's custom, right? So it's not like explicit one. It's get me one of those kind, right?
Yes, and those kinds are this in particular kind is a VF. So you're going to consume a VF off of
Sure.
a NIC. Okay, then if we go to the next example, it's okay. I want two VFs and one PF. So I want the whole PF. I don't know. You guys can help me with whether my terminology is correct. I think you can consume a whole PF, but we might need
No,
to.
that's correct. That
Okay.
sounds, it's possible.
So all you do is list it 3 times, right? So now that pod comes up, it's gonna end up, when it's all done, said and done, it's gonna have 3 interfaces. 2 of those are gonna be VFs, and one of them is gonna be a PF.
And the 2 of them, they're coming from NetDev 0, NetDev 1 is from the same device class. So so it's basically, if I route it with the device plugin model, it's really this example dot a colon 2. I'm requesting 2 devices of this class.
That's correct. It's just that in this simple form, we can't ask for 2. We'll see if instead you create a claim object, claim template sort of thing, you could ask for 2 at a time as a pair. But this, which allows you to put additional constraints on the
And does this matter? NetDev 0, NetDev 1, all this
those names are meaningless.
Okay.
They would be used if you cared about containers. They would be used here to mount them into particular containers. But since they're just required in the API, and I don't really have a way to.
So now those with John, in case those VFs are user space, they are not net devices. They are for DPDK, just bluntly. Then you have to mount them into the containers, right? The syspath has to be mounted. Yes, John. You cannot just
be used. Okay.
Only net device type devices can be pod level. Otherwise, they have to be in a specific container. Otherwise, it won't fly.
Well, not really. The VFs can be into the pod network namespace, right? I didn't understand your scenario, Marsha.
So if it's a user space application where I have to bind to a device like PCI address device, right? In this, I'm referring to a DPDK based application which uses user space stuff and uses rings and has to have access to the buffers, what's not. I'm throwing some names there, but basically there is no net device. There is no when I bind such device into a pod, when I IPA inside the pod, there is nothing. There's only ETH0, the default interface, but the other ones I don't see because those are just VFIO PCI mounted devices. And at that point, you do have to bind them, make them, mount them as specific path inside the specific container. This is because that's then not a net device, it's a path based, and basically you have to have it in a specific container. That's the separate path that we discussed last or 2 weeks ago. I'm not sure how you missed those meetings. We talked about that in our cases where VFs for the DPDK based stuff, we will have to do that this way, right? Because you have to mount it to the container. Otherwise, you don't.
Oh, so eventually, there will be use cases even for you to have this name here and mount it in the container for the DPDK. Sounds like.
Device nodes. I think Alexander has it right here. There is this device nodes basically, and those have to be those are paths. and you have to just mount them.
Okay, so that is possible in the that's a classic DRA example where you bind a device.
Yeah. That's the classic. That's how they deal with GPUs. So this is where
Exactly.
you just
Okay.
need to follow. Yeah.
Well,
Okay,
that
so let's go
name
to
in
the next.
question would be also important, correct? Because if you just specify 6 claims, how do you prevent ETH0 from being, the second? We need to have a name for like net 1, net 2, net 3, net 4.
Right. So this is
Otherwise, we'll
where
be
John is
failing.
getting to. I think
Well,
John
no,
is.
I think with the point, I don't know who that was. Was that?
That was
that
me.
So you're saying that, right, that we asked for 3 different things, like we want to be able to differentiate between them and mount them on the right interface name. So the driver would want to use those names for something, actually, even though we don't mount them individual containers. You would probably use them to correlate.
Yeah,
I think
what
there is.
Japa was trying to say, sorry, I think what Japa was trying to say is when all these network interfaces are mounted to the pod network namespace, right? So when you go inside the pod and you do IPA, you see ETH0, ETH1, ETH2, ETH3. Now you have 3 devices, let's say, in your previous example, which one will be mounted with 1, which will be mounted with 2, ETH3.
Right.
I don't know if it matters. Maybe if can let me put it this way.
Probably
Would you
matters.
pass this device name also to the device manager?
Yeah, that matters. And name is just one example, Neha. Keep in mind, I want to set a MAC address. I want to set an IP. I want to set any n number of configuration that you can think of. Think of the plumbing work group defined the whole JSON format
That is
of
correct.
annotations. So all that you
Yeah.
want to have that capabilities, let's say, right? So I assume, John, correct me if I'm wrong, claim is where I can put my additional configuration per claim. Is that true?
Yeah. So let's look at that. So this next example here, if we go back to the pod spec, so the reason it's called a template. So remember, there's 2 different types. There were 2 different forms we talked about in the pod, 3 different forms. One was list of names and classes that we saw. In that case, when you just list a name in a class, what happens is when the pod gets instantiated, we actually will have to create a claim in the background, because it's a top level object, and we'll associate it with that pod. And that gives us a place for status to land and things like that. Now, so that's effectively a template, right? Similarly, in existing DRA, we have something called a resource claim template, and we have something called a resource claim. In this prototype, we were given the sort of direction, let's try to reduce the number of top level types. And so we're like, well, the stuff in the template is exactly the same as the stuff in the claim, except that there's the additional object meta. And so we just reuse a claim. I'm not sure if it's a good idea or not. I'm not sure if that's where we'll land, because it is kind of confusing. I find it confusing, but we'll sort of see what API review prefers.
So what you're saying, the same claim can be a claim and a template.
Right, exactly. And so we have to figure out how to differentiate between that. But the main point is that templates, both when they're declared specifically template here in the pod spec, or when you have the name class pairs, they have the same life cycle as the pod. You create a new pod, like a deployment creates the new pod, it will automatically create a new claim. I don't have to manually, as a user, create those claims. When the pod's destroyed, those will be destroyed. That's different from the third form, which is just a claim name that's not serving as a template. That's I create the claim as a user. I point multiple pods at it. I can remove those pods and add those pods. That's for sharing the devices represented by that claim among pods. That's not something I think you have in the multi-net use case, but there is in the GPU use case.
So in this very example, John, you have this claim, and this claim, if you go a little scroll up, it has request devices too. Now, if I attach this claim to 2 pods, will both the pods are getting 2 devices of this class, or is it like shared?
So you probably wouldn't, or maybe couldn't even do that. If you did that, this is set up because it's got this word template here. This is set up to actually, you wouldn't be able to do that. This would create this device claim gets duplicated, basically, and a specific claim gets created associated with the same life cycle as this pod. That pod, we would make a request. In this case, we're making a request for 2 VFs on the same physical hardware card. and we're giving it to that pod. If you were to like not do this as a template and you were to create this claim independently, then you were to point to
Too specific.
pods
The
at it, it
previous
would be up to the
example.
driver to decide how to handle that situation. The scheduler would automatically force the second pod onto this. It's sort of a first come, first serve. Whichever pod gets scheduled first would allocate the claim. It's like lazy binding, right? It would actually pick the specific devices, which would pick you on the node, and then your driver would get that, and it would mount those interfaces into that pod sandbox. And then when the second pod came along, you'd be saying as a user, I want to use those same interfaces. I don't know if you can do that or not in your driver, or you're going to give an error. But that's kind of a driver specific behavior.
But then I can, in this case, I could have those example SROV across multiple nodes, right? This would mean, okay, why do you say exactly the same? Because this doesn't say anything about exactly the same.
Because
see, I can have hardware device name across multiple nodes, right? So if
yes,
this is
we're mixing up two things.
okay.
One is the templating, the multiple claims, and we're past time for networking. I think we're gonna need another. We should maybe book an hour for next time.
So we have a Wednesday. We have a Wednesday multi-networking 1 hour at 8. If that works for you, John, we can use that.
I can read it for the first half hour. The second half hour, I have other.
Okay, so at least that will be good as well, John.
You may have a conflict for the second half hour too. I think we have a common meeting. So
no, that's Wednesday, not that. I'm talking Wednesday, next Wednesday.
Okay. I know. Okay, we'll figure it out. But
all right.
But okay, so I want to get to the other stuff. But basically, right, there's two different structures here we're talking about. One is pointing two pods at the same materialized claim. That's not something I foresee as something. If we do that, you automatically are forced to the same node because that materialized claim is associated with a node. It's actually two actual real physical devices that it's talking about, and you're telling the platform, I want my pod to use those two devices. That's different than pointing it at the same template claim, which is saying that I have a pod, it's going to create its own materialized claim that's going to get then scheduled to some node. I have another pod, it's going to use the same template. At that time, I'm duping it anyway. I'm creating my own materialized claim, and it gets scheduled totally independently from the first pod. That's different than this match attributes hardware device name. This is for, I have two devices. They're landing on the same, because they're part of the same claim, they're going to be in the same node. I have some constraint on those devices. I want on those devices, I want them to come from the same NIC. I'm making up these names, things like NUMA, PCIe root, we'd see in the GPU world, where you'd say, I want a NIC and I want 4 GPUs and I want them all on the same PCI root. That's what these match attributes things are for. I don't care which PCIe root, just that it's the same across all of them. So we're going to need more time, unfortunately.
Yeah, I think there's still one more question. Sorry for the John taking more time. One question which hasn't still been solved. Can you go back to the previous example where you had 3 classes separately, netdev 0, 1, 2? I think what's going on in the chat is there is a scenario where we need pods to tell that to which interface you want to attach this device to. So in your scenario, will the kubelet pass this names also to the DRA manager?
If Patrick or Kevin, I think Kevin said he wasn't going to be here. I think Patrick was planning to be here. I'm 99% sure that's true, but Patrick could say 100% one way or the other.
Okay. So that's something, an open question we should also understand, because then in that case, if that gets passed, then we can use this name as the interface name, that it's 0, ith1, ith2, ith3.
I think it's part of the port, so it will be passed along. As you said, John, that we pass the whole claim and then all the parameters to the driver. So I assume you should get the whole thing.
Yeah, I'm assuming it too.
There are limits, right? Because things are going down through kubelet, through the driver, through like the CRI. Like, so there are. We'll have to make sure we can plumb everything through. I know Kevin in the past had to add things to this path. So there's also should certain things become available in like downward API? Like, I think there are definitely issues to discuss there. I'm not as familiar with the details of that, and so
And I think
holiday in Germany, so Patrick's not here, but yeah.
To answer your fully, this is where downward API will have to step in, because you would want to have some of this data inside the pod during runtime. So the two things, right? Configuration is one time, and then your runtime has to know, oh, net device 0 is connected to class X.
Exactly.
I do want to know that, right? So
I
that's
think
downward API where that has to step in.
Yeah, I think that information may not come from here. That information may come from some CR, because we still don't have a binding of which MAC address, which exactly NIC on the node you're gonna project it inside the pod, right? That is something a DRA specific implementation.
Yeah. Okay. Let's
Bruno, there's one hand.
We've eaten into a lot of time of the next group. Bruno, if you want to give a quick answer, a quick question, and then we'll.
Yeah, so I'm not sure, John, if we have the information flying down. I think two things need to be clarified: what the intersection of CNI and DRA will be here in terms of setting up the network devices, and how do we ensure there are no clashes between the names. So we'll need a path down the pod creation sandbox CRI. Maybe some details to work out.
Yeah, there's definitely work to do here. Okay, thank you. Okay, so Geeta, so the next half will still be of interest to the networking people, because we will look at the capacity model side. So this is how the driver advertises what devices are available on the node. So in classic DRA, this is done, the driver advertises it to a driver-specific CR. In 130, we added the ability to advertise this to something we call a named resource model, which is a named attributes model or something like that. Basically, you have a device, you have a bunch of static attributes associated with the device, and that's about it. In this prototype, what we're doing is extending that model to be more sophisticated, but it's still insufficient. And Patrick, were you here, would argue that we need a way to sort of make a switch and allow different models. And I'm starting to lean more towards what he's saying. But what I want to do is show you what we have so far in the prototype. So it's effectively an extension of what we call the named resources model. And from where I need help, we need help is to know if this model is going to be sufficient to support sufficiently expressive to support, say, what Geeta needs. Kevin's been closely involved, so we know it's pretty good for what NVIDIA needs. But let's take a look at the simplest one, which is we have two nodes and two simple GPUs. So we can go back and look at the classes, but I think it's probably better to just start with the examples, might be a little bit easier. We were talking earlier.
Thanks, John. So from our side, we have a list of use cases, very simplistic ones. So we'll be starting pretty simple, porting from device plugin to this mechanism. So I'll post the link, post the list here in the chat. These are the ones we would like to see a YAML for, if possible.
Sorry, my chat's not showing. I'm on and there's a lot of chat flying by. Can be sure, it's fine to put it in the chat for now, but be sure to put it in the, I guess we didn't put a section for this. We have that document that Neha started. I really want to get down to sorry, I'm trying to see what your messages were. Okay, count-based allocation. Okay, yeah, I really want to get down in that document. Like, we have some high-level use cases there. I want to get down to like really simple, pithy statements that I could make into these pod spec examples or into these pool examples. So
I'll add to the doc.
So like, if you look at my little descriptions at the top of each of these files, that's the level of like, I want a GPU, I want two GPUs on the same PCIe route, and the same model, but I don't care what model they are, right? Like something like that, right? That's a really simple description, and I can I express that? Now they have to come from a real point, right? Like I just made that up. I don't know if anybody would want to do that, but I want our end users and people to figure that out. So this is exactly, yeah, I love this. If you could be sure to add those to the document, then we can go through and try to evaluate it. But let's look at what we have so far. I don't think it's going to meet all your needs, but let's look at what we have so far. So basically, when the driver, all of the capacity models in something called a device pool. A device pool typically would come from a node, but there are use cases like networked devices and disaggregated devices that might not be associated with a node and eventually might, like at runtime, get assigned to a node. We're not trying to cover those use cases in 2024, 131 or 132, most likely, but just I'm making people aware of them. So generally, we would see a node name and we'd see a driver. So a driver owns a pool. You can create as many or as few pools per node as you want, and divide them up in a way that's appropriate for your driver. And you'll see some examples here of the way the current model works, the current prototype works. Here's an example. So this one we publish for node 0. These are attributes that are common across all the devices in the pool, the vendor, the model, firmware version, driver version. But then in here we have two devices, dev00, dev01, and we publish on a per device basis the NUMA node. In this particular case, they're on the same NUMA node. I don't know why I did that. Probably is a mistake. That's probably in my other example. Yeah, those are probably supposed to be different. But the idea is that this is where we get into that. We can do simplistic topology. We can't do complex topology. So if you look at a GPU, NVIDIA has like NVLink, which creates like a ring of GPUs. We're like so far from being able to do that in this model that it's not funny. But what we can do are super simple things like these are all on the same PCIe root. Not some massive tree through the PCIe tree, but like they're all on the same root, something like that. And these attributes will have to come up with somebody saying NUMA has nothing to do with devices. You're right. It may have nothing to do with devices. These are examples. We will come up with the ones that are appropriate. As I understand it, PCIe, and my understanding is quite limited, but you can have an association between a given CPU and NUMA node and PCIe root, but PCIe root is probably better. So so that's very, very simple. Then we extend it a little bit further.
So on that question on that, so today we publish a scheduler extension to achieve optimal placement with device plugin and scheduler extension combo. I'll put the link here.
Yeah.
This logic, will it fold into one entity essentially?
So it comes back to the claims. And when we make a claim, let's see which. I think probably if I just grab one of these like this, it's probably going to be fairly sophisticated. No, it's not great. So in the claims, you can create. Yeah, you know what I'll do. You can use these attributes to constrain. Okay, a claim, an individual claim, can be for one or more devices. But then we also allow you to do multiple claims because we want to get different devices from different drivers. So you can, at different levels, you can specify what we're calling right now match attributes, and we may come up with a different name. It's sort of like, a topology key, right? It's like you say, within this set, I don't care what value this attribute takes. I just want that all of the devices within that set have the same value. So model is a good one. I could say, I want to claim, I need 4 GPUs. I don't care if I get, A, B, or C model, but I need whatever, when I get those four, I need them all to be the same model, right? Or more interesting is PCIe root. I need to get four and I might care about them. I want four of this particular model. That would be in your constraints, model equals this. And I want them all to be on the same PCIe root because I know I'll get the best performance then. And if you can't satisfy that, don't give me anything, right? So it's kind of an all or nothing. So that's within an individual claim. But then I can also specify it at another level, which is when I have multiple claims, I can specify a match attribute across all of those. So I could say, I need those 4 GPUs, and I also need a NIC, and I want the NIC to be on the same PCI root as the GPUs, right? So I can specify it at that level as well. That's kind of what we're trying to get to with this match attributes. Now that doesn't, unfortunately, tie back directly to core compute resources. So if you have a scheduler extension that's looking at the core compute resources, or you're using Topology Manager, those aren't integrated in this current plan in this year. Like eventually, yes, we'd want to integrate those, but we have to limit our scope to something achievable.
So our scheduler extension is basically giving contiguous devices. So it's similar to, I think, the topology case you mentioned. We filter out nodes which are not satisfying the requested capacity in optimal way at the scheduler extension. It seems to me like we should be able to move that into the DRA framework and not use scheduler extension when we move to this.
You might be able to. It depends if you can represent that model in this relatively simple attribute matching expression. And so we have to look closely at what your model is like. I can't fit the NVIDIA. Kevin shared with me an algorithm they use, and like some of it can fit, right? There's like a PCIe root thing, but like then he starts to count links, like, oh, it's a ring topology, so it's like, is this 1 hop or 3 hops away, right? And I'm going to score differently based on that. That's not possible to express in the current proposal.
Okay.
So we'll have to look in quite detail on your actual algorithm and see if it's expressible.
Sounds
But
good. We can review that offline and sync up with you.
Okay, so then, so let me look. Let me just briefly. It's sort of like I'm going to go back and forth a little bit between the Go code, which tells you what you can possibly express, and then the examples, which express some versions of those. In the capacity types.go, you'll see the actual types. So what a device pool is, node name, driver, attributes. We saw those, right? Those are attributes that are common across all the devices. Skip this for a second. List of devices. List of devices is a device is just a name and a list of attributes that sort of override or overlay on top of the pool one. So if the pool one defines foo and the device one defines foo, the device one takes precedence. But generally it's used more for like, oh, it's just a denormalization. It's just a normalization thing where it's like, I'm going to normalize all of my devices are identical in this pool. I'll normalize all the attributes up there, but there's some small thing that's different between them, I don't know, and we'll, index or something, right? And then these last two things are where it gets a little bit more interesting. So NVIDIA has this use case, and actually I use it in the SRIOV use case too, and I need help from the networking people to see if anything I'm doing makes sense there. But NVIDIA has MIG, and what MIG does is allows you to take a single card and partition it into multiple cards. So what we did is, so Kevin came up with this clever algorithm or data model where basically he said, okay, when you allocate one of those partitions, you're essentially consuming resources from a common pool. So we define this concept of a common pool of shared resources that apply to, we're doing it in the device pool. So in this model, a MIG becomes a whole pool in and of itself. So one card becomes one device pool, and it's got a set of shared common resources. So I'll show you the example. It's probably easier to see. And then the individual types of partitions consume resources from that shared pool, so that when you actually allocate one partition, you're reducing the available shared pool, and that reduces the number of choices of partitions that are available. So let's see what the DGX one looks like. All right, 2 nodes, 1 DGX 100. So here's what the shared resources look like. Capacity, memory. So the overall parent device has 40 gigs. And then there's a bunch of other little things. And then there's these memory slices, and we'll talk about those in a minute, because this is how we kind of cover the card structure. So then let's look at individual devices. So an individual device then has something where it says shared resources consumed. So this is the one, use the whole card partition. So it says it would use all of the memory. And don't worry about the claims resources provided. That's another tier of functionality. So shared resources consumed. Okay, so as the scheduler is evaluating the possible ways to satisfy a claim, one of the things it would evaluate is it would look at each device. So we represent each possible partition as a device, and that the whole one is a possible partition, and it would consume 40 gigs. Another possible partition, another possible one is a small MIG, which uses 5 gigs. And so then the shared resources consumed in that particular device would have memory, this memory. So by iterating over all the possible combinations, we've created, we've given the scheduler all the options. If nothing's on the card and no partition's been consumed, then any of the 14 different arrangements, or really any of something like 14 different types of partitions would be available. The scheduler would have to decide which one to use. And at present, the plan is that the scheduler would find the best fit, which means probably the least waste, and would choose that one. Eventually, we'd need more sophisticated things than that, but that would be our starting point. So when it does that, it consumes those shared resources. Now, the interesting thing about MIG is that it's not just a pool of resources which are all equivalent. So when you consume one small partition, you've now, even though you've only used 5 gigs and there's still 35 gigs left on the card, there's one of the there's like physical layout issues. You've actually consumed part of the card so that other partitions disappear. So we've modeled those as these memory slices. So memory slice 0, this also, so there's 7 memory slices, and different partitions consume different memory slices. In this case, this one consumes memory slice 0. But then if you go to one of the ones that's like a larger partition, this one, these are all the small ones. They consume 0, 1, 2, 3, 4, 5, 6. But then a larger partition consumes 2 memory slices, memory slice 0 and memory slice 1. So that would strike off the available partitions for the next pod that comes along. Any that consumed slice 0 or slice 1 would no longer be available. So this allows us to actually be pretty expressive about not only can we consume a kind of shared pool of resources that's kind of very fungible, but we can actually, by creating specific resource names that align with specific physical parts of the card, and then tying the partitions to those, we can actually do even more. So that's super expressive. I don't know if you have that kind of need in the AWS.
I'm not sure how we will use it. Our mapping could be coarse. So we have at the resource is what we call a neuron core and a set of cores makes a neuron device. We do have use cases which ask for neuron cores. They may ask for neuron cores with certain attributes. I'm not sure how it will map. I think this one we have to look at, may or may not be applicable for
Okay.
our case.
So
The shared use case that we have in mind is quite different from this. That one is monitoring use case. So we have environment variables to mount devices into the daemon set which does monitoring. But is it possible to have a claim which says I want all devices in read-only mode, and it does the monitoring?
So yes, yes, that is something where we have that use case. NVIDIA has the same use case, and probably other people will too. Where you want it, we call it an administrative access claim. At one point, I modeled it in an early prototype as an access mode. So I had shared, I had exclusive access, shared read-only access, shared read-write access, and all those things. I don't have anybody telling me we need that right now. All I'm hearing we need is exclusive access. Well, there's different types of shared. I'll get to that, or I don't know that we'll have time to get to it, but I said, there's a provides claim resources. So there's another consumption model of fractional consumption, not using the partitioning, that supports. I'm not sure if we need that. We don't have time to cover it right now. But yes, let's get those detailed use cases and work together to iterate on this. There's a number of issues with this model. One is the one I mentioned earlier for multi-network, that like this model assumes you can list every device. Well, if we're creating VLAN interfaces, right, or VXLAN interfaces, we're not going to list every single one, right? So that's broken. And I think you probably have some use cases that are similar that will not work.
Yeah, it looks like we'll sync up offline through the doc. But if I could get two quick questions in.
Yeah,
One, can I leave so we use EFA, which is the RDMA from AWS. Can we leave that one to use device plugin and just move over the GPU to DRA? Will that be okay?
Probably. Like so one of the future meeting agenda items I put on the main work group agenda was, how do we migrate? Like
exactly.
what? Yeah, exactly. and I don't know. Yeah, we need to discuss that. I think
okay.
I think it's pretty much granted that we're going to have to allow the things to exist concurrently. There's no other way to do it. And the question, and potentially forever, not just like entering a migration period. So the question becomes like, yeah, how do we do that? I don't. There's probably 100 options we can choose, so we have to discuss it.
Okay, and the last quick question: health checking, is that built into the framework?
So we have a status area in this capacity model. So what we're seeing here is like the device pool spec, kind of the inventory, and then there's a status. This is saying allocated devices. So the idea is that you have conditions, just like you have node conditions, you'd have device conditions, and you could publish those there. And the scheduler, this says allocated. There's a sort of debate about whether this should be sparse or not. Like, probably this needs to just be not just allocated ones, because we need status at least of unhealthy ones. We may not need status of every single healthy one. That might be just like extra data we don't need to track, but we do need to know which ones are unhealthy. So yeah, so any requirements you have around what kind of details you'd want to put in there would be super helpful. We do know, we want to decide whether we should schedule against it or not, but there's also degraded performance. Like there's different ideas people have thrown around. I don't know what we're going to end up with, but any requirements you have would be useful.
Okay, just at a high level, of course, the details of what's wrong, and then the recommendation about what we want users to do when.
Okay. So okay, yeah, and you're talking about from the device the physical, like the actual device level. So there's two statuses. There's the status of actuating a claim on top of a device. So like if two claims are against the same device, which we haven't talked about, but that sharing mode,
Mhm.
you could theoretically have two different workloads sharing a device. Like they may have configuration associated with them, obviously it can't conflict and all this stuff. So like, anyway, there's attaching a status of attaching an individual claim to a device, and then there's the status of the underlying device itself. And we need both of those.
Correct. Yes. So I'm talking from the device perspective, like unrecoverable error, just terminate, things like that.
Right. Okay.
All
right. Awesome. We're out of time.
Yeah. Euros, before we close Euros, you want to bring up anything, any quick question? It looks like he dropped off already. Okay, we'll continue offline, I guess.
Yeah, let's continue offline. Anything, I haven't been able to follow the chat, obviously. So if there's anything important in there, somebody add it to the notes document. You could add a meeting to the main agenda notes document. We didn't do that yesterday. It's recorded anyway. We can go back and look. But anyway, awesome. Thank you so much. I hope it's helpful to you. It's certainly great to get some more use cases, and there's a lot of work to do, and we need to kind of get it wrapped up pretty fast. So we'll have to keep iterating.
Thank
So,
you.
Thank you so much.